Hey, good day and welcome. This is Mark Bates. I'm a metabolic health coach, and today's topic is the Randle cycle. And this handsome man you're seeing on the screen, that's Professor Bart K from New Zealand, one of my online mentors, and he says he's a handsome fellow. So I'm not going to argue with him. All right. Your cells make decisions about fuel use every second of your life. These molecular choices shape your health more than you might realize. At the heart of your cellular metabolism lies a pivotal regulatory system, the Randle cycle, first unveiled by Philip Randall in 1963. This system is not just a biochemical concept, but a key player in how your body safeguards itself at the cellular level. Most discussions about metabolism, though, miss the profound elegance of this system. The Randle cycle isn't just academic biochemistry, it's a window into how your body protects itself at the cellular level. So, what happens inside your cell? When we strip away the complexity, the Randle cycle reveals a fundamental truth. Your cells regulate which fuel they use based on what's available and safest. Here's the core principle. When cells burn fat, they simultaneously inhibit glucose utilization. When they burn glucose, they inhibit fat utilization. Those are the only two things your cells really burn for energy: glucose or fat. This reciprocal relationship creates a metabolic balance that prevents cellular damage. Think of the Randle cycle as your body's inbuilt security system, constantly monitoring and adjusting fuel usage to prevent cellular damage. The inhibition isn't binary, but operates on a spectrum. As fat oxidation increases, glucose utilization decreases proportionally. This isn't a design flaw, but a sophisticated regulatory mechanism refined over millions of years of evolution, or by design. The most fascinating aspect of the Randle cycle is how it protects cells from potential damage. When fat oxidation increases, it triggers a cascade of events that eventually locks the doors against excess glucose entry. This protective mechanism operates at multiple levels with increasing severity along the glycolytic pathway. The inhibition is most severe at pyruvate dehydrogenase (PDH), followed by phosphofructokinase 1 (PFK1), and then glucose uptake via GLUT4 transports, forming a coordinated cellular defense system. You don't have to know what all those other things were. Just understand your cell essentially, if it's burning fat, blocks the ability to intake glucose. Why would cells need to protect themselves from glucose? Excessive glucose can cause glycation damage, essentially caramelization proteins and lipids within the cell through a process similar to browning meat. So if you're eating too much glucose, essentially you're cooking yourself inside, right? Just think about it that way. Or another way people talk about it is that it's rust, right? Excess glucose is like rusting your cells. The cell's solution is brilliant. Sufficient energy from fat resources restricts glucose entry to prevent potential damage. Okay, just a quick note. Remember, please like, subscribe, and click the bell so you get notified on the next ones. Appreciate it. Okay, the process begins with when fatty acid oxidation produces acetyl-CoA, which builds up and increases the NDH and NAD plus ratio in mitochondria. Remember, the mitochondria where all this energy is produced. The end result from the mitochondria, from either glucose or fatty acids, is ATP, which is the universal energy source for all your cells. This surplus of acetyl-CoA generates citrate that moves into the cytosol. Cytosolic citrate then acts as a signaling molecule with a critical job. It directly inhibits key glycolytic enzymes. Some researchers describe this as a double lock. that prevents excess glucose utilization when fat is metabolized. The true beauty of this system lies in its precision. The inhibition isn't a simple on-off switch, but a finely tuned calibration that caters to the exact metabolic needs of the cell at any given moment. So remember, this is the way you were designed. You will either burn fat or glucose. And if you're burning fat, the cells are being locked so they don't bring in glucose. By the same token, if you're burning glucose, your body can't burn fat. So if you're trying to lose weight, the way to lose weight is to burn fat. Think about that. Okay? Understanding the Randle cycle changes how we think about metabolism and nutrition. It reveals that our bodies have sophisticated mechanisms for fuel selection that prioritize cellular protection. Consuming meals with high fat and high carbohydrate content forces the Randle cycle to make difficult decisions. The mixed signals can lead to suboptimal fuel utilization and potentially contribute to metabolic dysfunction over time. This may explain why some research suggests that diets that minimize simultaneous fat and carbohydrate consumption might offer metabolic advantages for specific individuals. So one of the things I always stress is don't bring in carbohydrates when you're eating fat and protein at the same time, which is where a carnivore type diet is perfect. You're eating fat and protein and you're not taking in any carbohydrates, right? Okay, the Randle cycle also contains an interesting phenomenon. When glucose uptake is inhibited during high fatty acid oxidation, the glucose that isn't oxidized doesn't simply disappear. Instead, it gets rerouted to glycogen stores. And glycogen is where your body stores glucose in the muscles and in your liver, right? This mechanism explains the rapid resynthesis of muscle glycogen after exercise and accounts for the increased glycogen content observed in muscles during fasting or diabetes. You're burning when you're fasting or you have diabetes, you're inhibiting glucose. Your body's trying to put that glucose somewhere, so it's going to put it as glycogen in your muscles. Your body isn't simply rejecting glucose, it's redirecting to storage when immediate oxidation isn't needed or would be potentially harmful. But remember, if you're eating too many carbs in the first place, you're not giving your body any choice. It's going to switch off the fat burning and go the Randle cycle, and it will turn on the glucose burning. Metabolic flexibility versus metabolic wisdom. While much of the discussion revolves around metabolic flexibility, the ability to switch between fat and carbohydrate metabolism, the Randle cycle suggests a more profound concept: metabolic wisdom. Your cells don't simply aim to burn whatever fuel is available, they make sophisticated decisions based on cellular protection, energy needs, and homeostatic regulation. This wisdom reflects millions of years of evolutionary pressure or the way your body was designed. Surviving cells develop protective mechanisms against potential damage from excess fuel substrate, i.e., eating too many carbs. Beyond the binary debate, the Randle cycle transcends the often polarized debate between carbs versus fats by revealing the nuanced interplay between these fuel sources. Both glucose and fatty acids serve essential roles in human metabolism. The key insight from the Randle cycle is that their utilization is precisely regulated to maintain cellular health. This regulation happens whether we understand it or not. However, understanding allows us to work with our biology rather than against it. And here's a key thing. Remember that if your body needs glucose in your blood for certain biological systems to work properly, your body has the ability through gluconeogenesis to convert excess amino acids and excess fatty acids into glucose. So your body will make all the glucose that it needs from the protein and fats that you're eating. There is no need to eat extraneous carbs. Okay, so you don't need to take in carbs, and the Randle cycle makes sure that those systems that need carbs are going to get them and burn them. Okay, what does this mean for everyday health decisions? While individual metabolic responses vary, the Randle cycle suggests several principles worth considering. First, mixed meals containing both high fat and high carbohydrate may create metabolic confusion at the cellular level. We're going to get right down to the cell level, and that's where your health starts. Right? This doesn't mean such meals are forbidden. They're just they're not suggested. But understanding the potential impact helps inform choices. Second, metabolic health might benefit from occasional periods where one fuel source predominates, allowing the Randle cycle to operate without conflicting signals. Finally, appreciate the protective nature of the Randle cycle. Helps us recognize that some metabolic responses we label as problems may be sophisticated protective mechanisms. Okay? I always like to go back to think about our Paleolithic and Neolithic ancestors. And when they're out hunting, when they make a big kill, they're eating protein and fat. When they're out hunting and they haven't killed anything yet, then they're picking berries. They might pick up a tuber that was growing wild, and they're eating carbs. They almost never mix carbs and protein and fat. Okay? So, while I don't eat a lot of carbs, I do have an occasional piece of fruit. I do have an occasional some spices and stuff with my meat for my carnivore. Think of it that way. It's very small amounts of carbs, and try not to mix a lot of carbs with your fat that you're taking in. Your cells contain wisdom beyond our conscious understanding. The Randle cycle represents just one example of the remarkable intelligence built into our physiology. When we may view metabolism through this lens, we move beyond simplistic models of calories and micronutrients to appreciate the sophisticated regulatory systems that maintain cellular health. The next time you eat, consider the cascade of biochemical decisions your cells will make about that meal. They're not passive participants, but active participants with protective mechanisms refined over evolutionary and adaptive time. This cellular intelligence deserves our respect and attention. After all, it kept our cells healthy long before we understood how it worked. Thanks for watching. Appreciate it. Bye.